Hello Internet, welcome to ipL. My name is Andreas and today we are talking about real-time market data feeds. I received a request to explain RTO, real-time optimized of the London Stock Exchange Group, and there isn't much about RTO that is not confidential and would not also be relevant for other similar feed solutions. Hence, I decided to have a broader look at this topic. Before we start, a short disclaimer. This video is not sponsored. Its purpose is to provide an overview and some examples to market data feeds and answers to frequently asked questions. And as always, for any questions or comments, please post in the comment sections and/or contact me via the form linked in the description. This short video is divided in 3 segments. First, we look at what real-time market data feeds actually are. Then we briefly dive into some variants of these feeds. And lastly, we will have a quick look at feed solutions of 4 sizable vendors in this segment. So, what actually is a market data feed? Well, let's ask a couple of search engines for their opinions. Asking Bing. Essential tools offering immediate access to financial information to allow users to make informed decisions. DuckDuckGo. Continuous stream of real-time financial information to help traders and investors make informed decisions. Sounds familiar, doesn't it? And Google, live up-to-the-second financial information to help traders, investors, institutions make informed decisions. Familiar again, right? We can see that the search engines are pretty consistent in how they describe real-time market data feeds, with the main difference in how they qualify the real-time part. Immediate, real-time, live, up to the second. What is important to highlight here, market data feeds provide you data of what has already happened. So this is not your trading feed that connects you with your brokers, market makers, or takers to send you orders. Market data feeds are mostly there for you to look at the data, analyze it, make calculations based on it, to weigh up your next steps. Now let us visualize the concept of market data feeds a little. We have 3 players or groups in this game. Venues, like your exchanges or other marketplaces. Vendors, like Bloomberg, Exegy, LSEG, SIX, who take the data from the venues, do something with it, which is usually normalization, and then sell it to the third group, which are the users, like banks, corporates, governmental institutions, and their respective applications. I have used the word normalization and will provide some more information to this later on. Back to the topic. Generally, we would distinguish between 2 kinds of market data feeds. One comes directly from the source, and these tend to be called direct feeds for that reason. The other comes through a vendor and hence is called a vendor feed. All these feeds connect via APIs, application programming interfaces, which can be developed as open or proprietary code. Open in this case means that the source code is available and everybody can amend, improve, or add to the code, either for their own use or to reshare with the general public. Open source is a common concept, but usually not applied when an API supports something that provides a competitive advantage. In such cases, the code is proprietary and either just a binary is changed, that's like you downloading and installing Microsoft Office, or you only get instructions on how to connect to a network address with specific parameters. That's like ordering a pizza via the phone. There is, however, also a competitive advantage to using open APIs like WebSocket. because the expertise required to program against an open API is usually wider spread and capable developers easier to come by. A developer familiar with proprietary APIs is usually more expensive and more difficult to substitute during off periods like vacations or sick leave. Hence, banks and other organizations tend to prefer solutions that support open technologies. Next, these feeds can either be connected straight to consumer applications or to a distribution system like the RTDS. If you've watched the RTDS video already, you will know what that system does. If you haven't, well, you should, of course. I linked it in the description. A distribution system connects to multiple sources, again via API, for example, multiple vendors, and your applications only connect to this one system to get data from all these vendors. The graph does not connect the direct feeds to a distribution system, but that would also be possible. How can we make things more tangible? We take your house, well, not literally, just figuratively speaking. Think of your water supply at home. You open the tap and out comes, well, water. But where does this water come from? You could get a contract with a nearby freshwater reservoir and get it from there. You could put a pump into a river and get water from there. And you could sneakily hook up a pipe to the fire hydrant and hope nobody notices. In all these cases, you have the advantage of knowing exactly what the water tastes like from each source. You will, however, have to treat the water chemically for each of these before you can drink it. This will be necessary in any case, but even more so during special events. There might be a drought that reduces the water volume in the lake, but won't reduce the amount of toxins in the water, meaning the remaining water becomes more toxic. Or there may be a lot of rain and flooding that pollutes the river, or some pollution in the sitting piping pollutes the water coming out of the fire hydrant. Each of these would require you to react and adjust your process. Alternatively, you could also contract with your favorite water supplier. They would get the water from the various sources. They will do the processing to make sure your water is clean before they send it your way. Same applies if you choose a lot of direct feeds instead of a vendor feed. There can be very good reasons to use direct feeds, but they will require additional effort on your side. On the other hand, like with you knowing what water from each source tastes like, with direct feeds you get pristine data and, in case of suspect data, don't need to wonder whether this is an issue at the source or at the vendor. Again, there are advantages to both approaches. With that out of the way, next we want to look at feed variants. Here we will look at the most prominent variants. First we have full tick feeds. This variant provides you with all concluded trades and also gives you every single quote update. These are your bids and asks. To get most value from this variant, you'd want to be using machine-driven processing. The human eye can only distinguish 3 updates per second, so there would be no real benefit using a full tick feed for desktop work. You'd unnecessarily tax your network and computers. What is this feed used for? Examples are pricing, you add your margin and then pass your new sales price to your clients. Then there is market analysis, risk management and trade strategy, where you look at market movements and relate these to local, regional or global events to evaluate risks and devise a winning strategy while limiting risk exposure. Or you want to build your own time series because perhaps your vendor or venue does not provide one or not in the way you'd like it. Intraday comes to mind. A full tick feed would lend itself to that task very well. Next we have the conflated feed. A conflated feed is usually trade safe. This means all concluded trades will be displayed. Unlike full tick feed, however, conflated feeds will only show you a reduced number of quote updates. So you will not get all your bid and ask updates, but only a limited number. The main reason for conflation is to reduce bandwidth and compute requirements. As mentioned, the human eye can only register 3 updates per second. So if that feed is only used for your desktop application, you would be just fine with a conflated feed. Also, if you are focusing on concluded trades, a larger number of bids and asks may not be in your interest. This feed type is perhaps the most widely used variant due to cost, computing and bandwidth requirements, as well as use cases. What is it used for? The use cases are largely identical to a full tick feed. I did not list time series here because the limited number of quote updates may not make it the perfect candidate unless you only use it to create a temporary intraday time series that you'd override with a vendor provided full tick version at the end of each day. Now that we looked at the quality of service options, let's check out quality of life. First, we have raw data. This is how you receive data usually through venue feeds, your direct feeds. Each venue has their own field map or field dictionary. Consequently, if you have feeds from 2 venues, you will end up with 2 maps, and your bid information, as an example, may not be in the same numerical field identifier. Both fields may be called bid, but one may be in field number 2 and the other in field number 15. What would you use raw data for? Well, you might not trust your vendor's normalization process. We will come to normalized data in a moment. You want the lowest latency, so any efforts of data beautification will be detrimental. You want to build your own data map to make troubleshooting of data inconsistencies easier. Like in our water example earlier, raw data means you will get the exact flavor of the source, and if data is off, it is highly likely that the issue is at the source and not at the vendor. On the flip side of raw data, we have normalized data. This is how you receive data usually through vendor feeds. Your vendor combines data from different venues into a single consolidated feed. To make it easier for you to compare and process different venues, your vendor normalizes the data. By that, we refer to them applying a data field map or a field dictionary across the entire feed. This map or dictionary identifies which content is displayed in which field. At LSEC, for example, field 22 contains bid values. As a user, you then know that you will get the bids from all venues you subscribe to through LSEC in this one field. Use cases are identical to the previously mentioned full tick and conflated feed variants. We looked at quality of service, quality of life, what's left but speed. First, let's look at low latency feeds. This is a bit contentious, not so much by content but by name. The vast majority of real-time market data feeds feature low latency delivery. Yet, the term low latency was commonly used for lower latency. At the same time, when you look at vendor websites, you won't find any of them not promoting their normal or basic real-time market data feeds as low latency products. For this reason, I consider these normal or basic real-time feeds part of the low latency group and will, after this, touch on the faster variants in the ultra-low segment. Enough of the prelude, what do we have? Latency of these feeds usually ranges between 5 and 100 milliseconds. The speed is not so much vendor specific, but a function of geographical distance. The farther from the source you are, the longer it takes for the signal or update to reach you. The higher is the latency incurred. Compare this to the speed of sound, which is roughly 300 meters per second. Have you ever tried to identify how far a thunderstorm is away from your location? You'd wait for the lightning and then count the seconds until you hear thunder. 3 seconds between lightning and thunder roughly equal 1 kilometer. 6 seconds, 2 kilometers. Now consider the lightning, the moment when your venue sends a quote update. If someone at the exchange was shouting this update out of a window really loudly and you are 1 kilometer away, you'd hear it after 3 seconds. Your latency would be 3 seconds. As mentioned, this variant is the most frequently used type of market data feed. What would you use it for? Again, the use cases are the ones we mentioned in previous variants. From the highway to the German Autobahn, let's look at the ultra-low latency feed variant. To take advantage of ultra-low latency feeds, you will need to co-locate your applications with the venues. This means you rent rack space in the same data center that houses the exchange you want to work with. Any meaningful distance that exceeds the proverbial length of a patch cord will impact the value you get from your business because it makes you potentially slower than your competitors. For the reason of speed, data consumed from ultra-low latency feeds usually is also raw, not normalized. As you are likely looking only at a single venue at a time, normalization would also not help you much. What are these feeds used for? There's only really one prominent use case, and that is algorithmic trading. The moment the exchange posts an update, you want your algorithm to have it so it can adapt your pricing and issue new orders in a fraction of a second. Before we look at vendor feeds in some more detail, let us put some feed examples next to the variants. Full tick examples are Bloomberg bpipe, LSEG full tick, formerly known as RTMDS, and 6MDF stream. I did not add exegy solutions here because I could not quite identify from their information whether it is full tick or conflated, though I believe their feeds are full tick. Conflated feed examples are, again, Bloomberg bpipe, although you would explicitly have to ask them for a conflated version, LSEG real-time optimized or RTO, as well as 6MDF stream. Again, not sure if exegy provides conflated feed options. Raw data format is what you get through direct feeds, exegy NX feed and LSEG Ultra Direct, formerly known as May Street. Normalized data is what all vendors offer, Bloomberg bpipe, exegy Axiom, LSEG all but the Ultra Direct version, and 6MDF stream. Low latency feeds comprise offerings like Bloomberg bpipe, exegy SMDS, LSEG all but Ultra Direct, and 6MDF stream. Ultra low latency feed examples are exegy NX feed and LSEG Ultra Direct. Now to some vendor feed details. The following table was compiled from information available on the websites of the respective vendors. Looking at this table, it is easy to see that LSEG offers the largest volume of instruments from the largest number of contributors. However, this does not automatically convert to leading in every market segment. Each vendor has strengths and weaknesses, and your choice should align your individual requirements to the strengths of each vendor. Time series at the bottom of the table is not actually a streaming real-time feed product, but rather the result of such a product. And because it is a necessary companion to real-time feeds, I added the information into this table regardless. When I say necessary companion, then this refers to regulatory requirements for best execution, etc. As an example, you are a salesperson at a bank and I call you to ask you to purchase a bunch of shares on my behalf. Once the trade has been concluded, I have the feeling that the rate at which you executed for me was not particularly good. So I challenge you, and you will have a limited period of time to provide proof that the rate you accepted was indeed market conformant. To do this, you take the date and timestamp of the concluded order and underlay it with market data, asks, bids, trades before and after execution. This data you'd get from time series. which you either have access to or need to contact your vendor for. Given the urgency of having to fulfill such a request, it is advisable to have ready access to time series solutions. This is just one example, of course. When subscribing to real-time market data feeds, or any kind of market data feed for that matter, make sure you identify your use cases in detail before going into negotiations. Different use cases will result in different licenses, which will come at different price points. Is the data just for your users to look at? Are they storing the data to process it? Is data used in non-display applications? Are you redistributing the data to your customers? Make sure you are very clear before you sign the paper to avoid penalties later on. Not always is the cheapest initial offer the cheapest once you look at it in detail. It is a potential minefield. Be prepared. While there are main players in the vendor market, which I mentioned a few of during this video, there are also an increasing number of fintechs entering the game that may be worth checking out. And this concludes this session. I hope you enjoyed it and found it useful. Leave a like or comment, or contact me through the form linked in the description, and I hope to see you again soon. Bye bye.